This is the very first step. And second step is to find the upper bound. Here you just see this condition that you are provided with a bag that holds for 15 kilograms. That means we try to stock all the products that we
ఎల్లి చిన్న పెట్టుకో చదువుకోవాలంటే.
see. You just mute your mics. So we try to stack all the items in our bag such that it should hold the maximum number of weight and its values. That means the concept here it is maximization. We just compare with the problem that we have learned here. That is minimization. Why? Because we have to find the minimum time to complete the entire thing. That is minimization problem. Here we are going to consider maximization. That means we have to find the maximum value such that it can hold the capacity of the entire bag and its value. So in case of assignment problem, we have learned to calculate the lower bound. Why? Because that's maximization. In case of knapsack, we have to find the maximum value. So we have to find the upper bound. That's the main difference here. So the formula for calculating this upper bound is this way. Your value. This capital W is nothing but your capacity. We already provided that the capacity of this entire sack is 10 kilograms. So we can't able to place if it goes for 10.5 kg. Our entire sack will not accept it. So we have to find the possibility of placing those items. And VI plus 1, WI plus 1, nothing but item numbers. In case of if you are solving for item number 1's upper bound, you will be calculating for second values VI plus 1 and WI plus 1. That will be seen later. In case of step 3, you have to construct a root node. So at the very beginning, you have to find what is the capacity for this entire bag. So by without placing any item, you have to find the capacity here. So at the very beginning, see here, this bag, I am not going to place any item in this bag. So that's what here it is given. So since the item is 0, we are not going to place any item. So obviously its weight and value is 0. So if you substitute in this formula, you will be getting its upper bound value is 100. You might have got the question, how can we determine it should be 100? That is somewhat related to theoretical computer sciences. So we'll be getting, while solving these type of formulas, we'll be having a value, but we can't predict that could be the actual answer. So we can find that might be the average answer. In case of theoretical science, that's the rule. So you have to apply in this formula where we are not going to consider any items. So obviously it won't have any value and it won't have any weight. According to Lee, we won't have any values per kilogram weight as well. So if we solve in this way, we'll be getting this one as the answer. So we can say upper bound is 100. So I can say we have whenever we are not going to place anything, it can hold for 10 kilos. What happens when I'm going to place with and without? This problem is something that we have learned in our subset of sum problems. That means what happens when I'm going to place with item 1 and when I'm not going to place in item 2. I think we have learned this one in our third unit. So we have to check our batch capacity. So again, you just consider here. See this one. So item 1, its weight is 4, value is 4, value per kilogram is for what happens when I'm going to consider with item 1, its weight is 4 and value is 4. In case of calculating this upper bound, I'm just going to replace everything. In case of VI plus 1, WI plus 1, that means here I value is 1. Here we are going to consider the next item's value 1 per kilogram. Note this point, we are not going to consider for this item 1 kilogram per weight value. We are going to consider item 2's kilogram per weight value. That's what. That means this value that is going to get substituted and the upper bound value is 70. And without placing this item 1, so I'm not here. I'm not going to place item one again. This value, this node value is going to get repeated. That means for item one, it is again zero. Its value is also again zero. I'm going to repeat everything where W is the capacity. That is correct. And VI plus one WI plus again 6. So you just consider here it is 76 and here it is 6. Previously, our main motive is to stack more number of items in our bag. So we have to find the bag capacity should be greater. That means maximization problem. Comparatively, 76 is our higher value. So this is the point where we have to branch in our entire problem. That's what here it is. This is so. While placing with item 1, we have got 76. So from 76 onwards, we have to branch. So this is our bond. From this bond, we have to branch. Here it is. And next is, again, you just see this tabulation once again. Now we have considered for item 1. Again, now we have to learn this. Now we have to consider for this item 2. So what happens when you are going to place item 2 in your bag, and what happens when you are not considering this item 2? What could be the capacity? So what happens when I'm going to place with item 2 and without item 2? So according to this tabulation, we are going to consider this item 2. We just reconsider this previous tree here. We have considered this item 1. That means in our bag we have placed item 1. That means item 1's weight is 4 kilogram and its value is $40. This item is actually in our bag. Why? Because we are just proceeding from that node onwards, right? So even though you are adding your second item, already you have to add the previous value as well. Why? Because in your sack, item 1 is also available. So when you are placing this item 2, its value is 7 and its value is $82. But you just see this condition here. Weight of this, when you place this item 1 and item 2, its weight goes beyond 11 kgs. That means our actual bag capacity is 10 kilogram. So it is not feasible. Feasible means it is not giving true to our actual condition. So we can consider this one as our we can consider this option. So obviously we have to eliminate it. What happens when you are not placing this item 2 in your bag? Again, just see here this condition. The previous value item 1's value and weight would be remade. Yeah, its value weight is 4 and value is 40. When you are placing this item 2, you just replace everything. And in case of finding this item 2's upper bound, you will be considering for item 3's weight per value, per kg weight, that is 5. To this table, item 3 per kg value is 5. That's what we have done here. So while solving it, here it is not feasible. Again, we can't go in this value. Again, 70. It is the only option in order to solve the entire problem. So we are just branching from here onwards. So that's what we will do in this time. So we have to again branch from this level onwards. We have to try with item 3 and item 4 as well. So from here, from this node onwards, we have to check what happens when you are going to place item 3 and without placing item 3. So this is. So with item 3, see this case. Till now we have placed only item 1 in your bag and we are not placing item 2. So our bag contains only this weight and this value. So item 2 will not be considered in case of item 3. So that's what we did. So where item 3's weight is 5 kilograms and value is $25. That's what added here. Where its weight now becomes 9 kilograms. That means it is actually lesser than our actual capacity. Actual capacity is 10 kg. So if you substitute, you got the upper bound value as 69. Again, once you didn't place this item 3, you got this upper bound value as 64. Again, the problem leads to maximization. You have to find a lot of spaces for it. So again, we'll be going with whatever the value that has higher precedence. So we'll be selecting with item 3. That's what here. So we didn't place item 2 in your bag, and we have placed with item 3, and we have to branch from here onwards. So what happens when you are going to place item 4 and when you didn't place item 4? So when you place this item 4, so far we have this bag capacity is adding one's value, one's weight, and item 3 is weight. That's what. Totally it has got 9. Again with adding item 4 value is 3 and its weight is 3 and its value is $77. Again its weight is 12. It is beyond our actual capacity, so it is not feasible. So again you have to consider without placing this item 4, you have got this value as 65. So this is our actual answer. So if you repeat in this manner, we can say actual branching and bounding value could be approach could be used to solve this problem. So you have any doubt?